The 2005 edition of NFPA 70, the National Electrical Code, also known as the NEC, has been adopted by numerous states to strengthen public safety. The NEC serves as the blueprint for electrical safety across the United States and around the world. Many state and local governments update their electrical code adoptions every 3 years in conjunction with the NEC revision cycle. The quality of the 2005 NEC has led many states to adopt it. The added provisions in the 2005 NEC have strengthened public safety. The focus is on providing the safest electrical requirements possible, and the 2005 NEC provides the best set of safety requirements ever found in an electrical code. States currently using the 2005 NEC include Colorado, Idaho, Massachusetts, Nebraska, New Hampshire, North Carolina, North Dakota, Ohio, Oklahoma, Oregon, South Carolina, Texas, Washington, and Wyoming. Many other states have started the process of updating their current NEC adoption to include the 2005 edition. The NEC has long been the world's most widely adopted safety code. The 2005 edition of the code offers additional safety requirements to protect people and property against fire and shock hazards associated with the use of electricity. The 2005 NEC offers stronger protection against electric shock. It expands requirements for ground fault circuit interrupters, also known as GFCIs, calling for the devices to be used more extensively in homes, businesses, and public places. Greater protections against fire are also included. The 2005 NEC requires the use of the latest in arc fault circuit interrupter, also known as FSI, technology. New safeguards for electrical workers are present. The 2005 NEC contains new provisions that are designed to minimize shock and burn hazards faced by those who install and service electrical systems. There is increased reliability of emergency systems. The 2005 NEC requires that built-in emergency systems intended to provide occupant safety in the event of fire or other disaster include operational safeguards that will increase the reliability of these important public safety systems. The aim is to have these and other electrical safety provisions in place, which is why many worked quickly to adopt and begin using the 2005 NEC. Since 1911, the NFPA has been the developer of the NEC. The NEC is part of a full set of codes for the built environment developed by the NFPA and its partners. The 300 NFPA technical committees responsible for developing and updating codes and standards include 6,000 volunteers, representing enforcing authorities, installation and maintenance, labor research and testing, insurance special experts, consumers, and other users. The NFPA has been a worldwide leader in providing fire, electrical, building, and life safety to the public since 1896. The mission of the international non-profit organization is to reduce the worldwide burden of fire and other hazards on the quality of life by providing and advocating consensus codes and standards, research, training, and education. The 2005 NEC enhances shock protection with expanded requirements for ground fault circuit interrupters, or GFCIs. It increases fire prevention through the requirement for arc fault circuit interrupter, or FSI, technology. It provides safeguards for electrical workers by adding new provisions to minimize shock and burn hazards. It also improves the reliability of emergency systems through operational safeguards designed to increase the reliability of emergency building systems. Ground fault circuit interrupters, or GFCIs, are crucial safety devices designed to protect people from electrical shock. They work by monitoring the current flowing in a circuit and quickly cutting off the power if they detect a leakage current to ground. This leakage current, even a small amount, can be dangerous and potentially fatal if a person comes into contact with it. The 2005 NEC expands the requirements for GFCIs, mandating their use in more locations, especially in areas where water is present or where people are likely to be in contact with the ground. This includes bathrooms, kitchens, outdoors, and other damp or wet locations. By requiring GFCIs in these areas, the code significantly reduces the risk of electrical shock. Arc fault circuit interrupters, or FSIs, are another essential safety technology aimed at preventing electrical fires. Arc faults occur when electricity jumps between conductors, creating a spark that can ignite nearby flammable materials. These types of faults are often caused by damaged wiring, loose connections, or worn insulation. ASIs are designed to detect these arc faults and quickly shut off the power to the circuit before a fire can start. The 2005 NEC requires the use of ASI technology in more areas of the home, particularly in bedrooms, living rooms, and other areas where people spend a significant amount of time. This requirement helps to protect against fires caused by faulty wiring and other electrical hazards. The 2005 NEC also includes new provisions to enhance the safety of electrical workers. These provisions focus on minimizing the risk of shock and burn injuries during the installation, maintenance, and repair of electrical systems. The code mandates the use of appropriate personal protective equipment, or PPE, such as gloves, eye protection, and insulated tools. It also requires the implementation of lockout-tagout procedures to ensure that circuits are de-energized before work begins. Additionally, the 2005 NEC emphasizes the importance of proper training and qualification for electrical workers, ensuring that they have the knowledge and skills necessary to perform their jobs safely. Emergency systems are critical for ensuring the safety of building occupants during fires and other disasters. These systems include emergency lighting, fire alarms, and backup power systems. The 2005 NEC includes requirements to increase the reliability of these systems. The code mandates that emergency systems be designed and installed to operate independently of the normal power supply. It also requires regular testing and maintenance to ensure that the systems are functioning properly. Additionally, the 2005 NEC includes provisions for monitoring the performance of emergency systems and providing alerts if any problems are detected. The NEC is updated every 3 years to incorporate new technologies, address emerging safety concerns, and improve the overall safety of electrical installations. The process of updating the NEC involves a collaborative effort of experts from various fields, including electrical engineers, contractors, inspectors, and manufacturers. The proposed changes to the code are reviewed and debated by technical committees, and public input is also considered. The goal of this rigorous process is to ensure that the NEC remains the most comprehensive and effective electrical safety code in the world. The NEC is not just a set of rules, it is a living document that evolves to meet the changing needs of the electrical industry and the public. By staying up to date with the latest edition of the NEC and implementing its requirements, we can create safer electrical environments for ourselves, our families, and our communities. The NEC, developed by the National Fire Protection Association, has a long history of promoting electrical safety. The code's evolution reflects advancements in technology and a deeper understanding of electrical hazards. Each revision builds upon previous editions, incorporating lessons learned from past incidents and aiming to prevent future ones. The NEC is organized into chapters and articles, covering a wide range of topics, from general wiring requirements to specific rules for different types of equipment and installations. It addresses issues such as conductor sizing, overcurrent protection, grounding, and wiring methods. The code also includes detailed tables and examples to help users apply the rules correctly. One of the key principles of the NEC is to protect people and property from electrical hazards. This is achieved through a combination of prescriptive requirements and performance-based standards. Prescriptive requirements specify exactly how something must be done, while performance-based standards define the desired outcome and allow flexibility in how it is achieved. The NEC also emphasizes the importance of proper installation and maintenance. Even the best designed electrical system can be unsafe if it is not installed or maintained properly. The code includes requirements for qualified personnel, inspections, and testing to ensure that electrical systems are safe and reliable. The NEC is widely adopted by state and local governments throughout the United States. While the NEC itself is not a law, it becomes legally binding when it is adopted by a jurisdiction. This means that electrical installations in that jurisdiction must comply with the requirements of the adopted edition of the NEC. Some jurisdictions may also make amendments to the NEC to address local conditions or concerns. It is important to check with the local authorities to determine which edition of the NEC is in effect and whether there are any local amendments. The NEC is a valuable resource for anyone involved in the electrical industry, including electricians, contractors, engineers, inspectors, and manufacturers. It provides a comprehensive set of rules and guidelines for safe electrical installations. The NEC is also a useful tool for homeowners and business owners who want to understand the electrical systems in their buildings and ensure that they are safe. There are many resources available to help people learn about the NEC. The NFPA offers training courses, publications, and online resources. There are also many other organizations that provide information and education on the NEC. By taking advantage of these resources, people can gain a better understanding of the NEC and how to apply it in their work or in their own homes. The NEC is not just a technical document, it is a reflection of our commitment to safety. By following the requirements of the NEC, we can create safer electrical environments for ourselves and for future generations. Electrical safety is a shared responsibility. It requires the cooperation of everyone involved in the electrical industry, as well as the public at large. By working together, we can reduce the risk of electrical accidents and make our communities safer. The 2005 NEC, with its emphasis on ground fault circuit interrupters, arc fault circuit interrupters, and worker safety, represents a significant step forward in electrical safety. By understanding and implementing the requirements of this code, we can protect ourselves and others from the hazards of electricity. The NEC continues to evolve, with each new edition incorporating the latest advancements in technology and safety practices. Staying informed about the NEC and its requirements is essential for anyone who works with electricity or who wants to ensure the safety of their electrical systems. The NEC is a valuable tool for promoting electrical safety and protecting people and property from electrical hazards. The enhanced shock protection provided by expanded GFCI requirements is a significant advancement in electrical safety. GFCIs are designed to protect people from dangerous electrical shocks that can occur when there is a ground fault. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs work by monitoring the current flowing in a circuit and quickly interrupting the power if they detect a ground fault. This interruption occurs within milliseconds, which is fast enough to prevent serious injury or death. The 2005 NEC expands the requirements for GFCIs, requiring them to be installed in more locations where people are likely to come into contact with water or other conductive materials. This includes bathrooms, kitchens, laundry rooms, and outdoor areas. The increased use of GFCIs will significantly reduce the risk of electrical shock in these areas. The increased fire prevention provided by the requirement for FSI technology is another important safety improvement. FSIs are designed to protect against fires caused by arc faults. Arc faults occur when there is an unintentional electrical discharge between two or more conductors. These discharges can generate high temperatures that can ignite nearby flammable materials. FSIs work by monitoring the current flowing in a circuit and detecting the unique characteristics of arc faults. When an arc fault is detected, the FSI quickly interrupts the power to the circuit, preventing a fire from starting. The 2005 NEC requires the use of FSIs in more areas of the home, including bedrooms, living rooms, and dining rooms. This increased use of FSIs will significantly reduce the risk of electrical fires in these areas. The safeguards for electrical workers provided by the new provisions to minimize shock and burn hazards are also an important improvement. Electrical work can be dangerous, and electrical workers are at risk of being shocked or burned if they are not properly trained and equipped. The 2005 NEC includes new provisions to protect electrical workers from these hazards. These provisions include requirements for personal protective equipment such as gloves, eye protection, and insulated tools. They also include requirements for lockout-tagout procedures to ensure that electrical circuits are de-energized before work begins. These new safeguards will help to reduce the number of electrical accidents and injuries among electrical workers. The improved reliability of emergency systems provided by operational safeguards to increase the reliability of emergency building systems is yet another important safety improvement. Emergency systems are designed to provide essential services during emergencies such as fires, power outages, and natural disasters. These systems include emergency lighting, fire alarms, and backup power systems. The 2005 NEC includes new provisions to increase the reliability of these systems. These provisions include requirements for regular testing and maintenance, as well as requirements for backup power sources. These new safeguards will help to ensure that emergency systems are available when they are needed most. The 2005 NEC is a comprehensive set of rules and guidelines for safe electrical installations. By following the requirements of this code, we can protect ourselves and others from the hazards of electricity.